at our last new information for the unit. So we're going to take a look at problem solving using measurement. So question number 1, we're going to determine the volume and surface area of the solid below. And when we do this, we want to really pay attention to what parts of the formula are included and what might not be included. So if we're going to determine volume, notice that volume is to fill an object. So if we have two different shapes like we do here, we have our rectangular prism and we have our triangular prism, we can just find the volume of each of those shapes and add it together because we're just going to fill the whole thing. So volume, and starting with our formulas, we know that the rectangular prism, we're going to have length times width plus height. The triangular prism, we have base times height times length divided by 2. And subbing in what we know here, we have our length times our width times our height in our base times height times length divided by 2. Notice that this 1.6 is the entire height here. So the height of our triangular prism is just going to be 1.6 minus the 0.4. So just the triangle is going to be 1.2 for the height. So we're going to have our base of 2 times our 1.2 times our length, which is 2. And simplifying and adding together, and again, we can do this all in one step in our calculators. 2 times 2 times 0.4 plus bracket 2 times 1.2 times 2. And when we do that, we get, and again, rounding to 1 decimal place, we get 4 cubic meters. Now, for surface area, starting with the formulas for our surface area. So we have surface area of our triangular prism, we know is going to be 2 times base times height divided by 2. The two ends are our triangles. And we have 2 base times slant, 2 slant times length. And the one on the bottom of our triangular prism isn't there. It's not on the outside. Remember, we're just adding up all the sides of our object and we're only including the outsides. So we're not going to have the base times length that we normally would, okay? So this is our triangular prism. Minus the bottom. Now, for our rectangular prism, again, thinking about our 2 length times width plus 2 width times height plus 2 length times height, but this case, the top of our rectangular prism is not on the outside. So we are only going to include the bottom of the rectangular prism, not the top. So we're going to have length times width plus 2 width times height plus 2 length times height. And again, just to make note of this, this is our rectangular prism minus the top. So subbing in our numbers here, we're going to have 2 times base times height divided by 2. We're going to have 2, and notice we don't have the slant, okay? So we're going to go back over here, and we're going to have to use our slant squared equals, And notice that we're going to be using our right angle triangle in here. So we're going to have our 1.2 squared plus half of the base of the triangle, which is just 1. So 1.2 squared plus 1 squared, get our answer, divide by 2, and keeping some extra decimal places, we're going to get a slant height of 1.5620, which we can now sub into our formula. And for our rectangular prism, we're going to have 2 times 2 plus 2 times 2 times 0.4 plus 2 times 2 times 0.4 as well. And simplifying, just making sure we have all the right values here, we get 2.4 plus 6.248 plus 4 plus 1.6 plus 1.6, giving us a total of 15.8 square meters. And again, we double check our units. Volume is cubic units, surface area is square units, and just double check that everything makes sense. Example number 2. Now we have what could be a silo. So this is the shape that we a lot of times see on a farm with our cylinder and half a sphere on top. What we want to do is come up with our formula for volume and surface area of our shape. So let's start with our volume. So our volume of our sphere is 4/3 pi r cubed, but we only have half of the sphere, so we have to divide that by 2. And we're going to add the volume of our cylinder, which is pi r squared h. Now, over here, we're going to just make sure and figure out exactly what 4/3 divided by 2 is. Well, 4/3 divided by 2, remember we can't divide fractions, so we're going to make that 4/3 times 1/2, copy, flip, flip, and we get 4/6, which simplifies to 2/3. So simplifying this, we're going to get 2/3 pi r cubed plus pi r squared h. And we're going to leave it at that. That's about as simplified as we can make this without making it more difficult. Our surface area, again, thinking about only what's on the outside. So our surface area of half a sphere, we're going to have 4 pi r squared is surface area of a sphere, but again, we only have half of it. Then we're going to have our cylinder. Our cylinder usually has 2 pi r squareds for the top and bottom circles, but the top circle is not on the outside of the object, so we're only going to include 1 pi r squared. And for our lateral surface area of our cylinder, we're going to have 2 pi r h. So simplifying, we have 4 divided by 2 is going to leave us with 2 pi r squared plus pi r squared plus 2 pi r h. And now we notice that we can simplify. Pi r squareds are the same, so we can add them together. We're going to have 3 pi r squareds plus 2 pi r h. And that's going to be our formula that we could now sub in our values once we know those measurements. And example number 3. A hollow chocolate sphere is 12 centimeters in diameter and 1 centimeter thick. We want to calculate the volume of chocolate in the sphere. So what we're going to do is sort of take a side view of this. So we're talking about a ball of chocolate, which gives us a big sphere. And sorry, that's not a great circle, but we'll get the idea here. And inside of it, it's hollow. So the whole thing is 12 centimeters in diameter and 1 centimeter thick. So we want the volume of chocolate. Volume of a sphere is going to be 4/3 pi r cubed. So we're going to talk about the whole thing as how much space it occupies. Now the chocolate though is not in the middle. So that's another sphere in the middle that we're going to now take away. So we're going to take away from the amount of chocolate, the amount of air inside the chocolate. So we just have to figure out the radius of each of these spheres. Well, the outside sphere, so our outside sphere is going to be 12 divided by 2, which means we have 6 inches in radius for the big sphere. On the inside, we have to remember that we have 1 inch of chocolate on either side, which means that we're going to have 10 inches in diameter on the middle, which again we have to divide by 2, and we're going to get 5. So the radius of the big sphere is 6, radius of the inside sphere is 5. And we can do this all in our calculator in one big step. So we can do 4 divided by 3 times pi times 6 cubed, or you can start with the 6 cubed times pi times 4 divided by 3 minus, oh, and sorry, we need our pi in there, minus bracket, and do the last part in brackets. And we're going to round to 1 decimal place. So when we do that, we should get 381.2 cubic centimeters. So the volume of chocolate is 381.2 centimeters cubed, which is equal to 381.2 milliliters. Okay, 1 cubic centimeter is equal to 1 milliliter. So we can talk about it in milliliters as well. Okay, so some questions to practice, again from your textbook, listed the questions there. I've also put a link to a formula sheet for your review. So if you want to print that off and use that,